In this lecture, we are going to talk about concrete examples as far as a one-dimensional array is concerned. So first of all, how to create an array in Python. First of all, we have to define a variable. I'm going to use an array, and we have to use brackets like this. So for example, I will use 10, then 3, then 7, then 5 finally. Okay, so in this case we have 4 integers stored in a one-dimensional array. So if we want to print out all the items, then for example we can do something like this. So if I run it, then as you can see we can print out all the items present in the one-dimensional array. If we want to print out the first item or the second item or one of the items of the array, we have to use indices. And this is called random indexing. So random indexing means that we are able to access the given items based on indices. The index 0 is going to represent the first item, index 1 represents the second item, index 2 has something to do with the third item, and so on. So what's crucial that indices starts with 0. So for example, if I would like to get the first item, what do we have to do? We have to use index 0. So if I run it again, then as you can see, the first item is going to be printed out. So the first item with index 0. What about if I want to print out the second item? The second item has index 1. So if I run it, then 3 is going to be printed out. This is called random indexing, that every single item in a one-dimensional array, or basically in a two-dimensional or a three-dimensional array as well. So whenever we are dealing with arrays, we use indices. We identify the items with indices, and this is why getting a given item based on a given index is extremely fast, order 1 constant running time complexity. What if we would like to get all the items? Then we can use something like this. So this is how we fetch all the items present in the one-dimensional array. So again, if I run it, then the result is going to be the whole one-dimensional array. What if we would like to get, for example, the first 3 items? So for example, starting with index 0 up to index 2 exclusively. So if I run it, you can check that index 2 is not going to be returned. So basically it is going to return all the items starting with index 1 up to index 2 exclusive, which means that index 2 is not going to be present in the result list. Okay, so if I do something like this, that 1 and 3, then the result is going to be 3 and 7, because 3 has index 1, then index 2, and index 3 is not going to be included in the result set. What if we would like to get all the items except for the last one? We can use something like this, -1. It means that we are going to get all the items except for the last one, so the result is going to be 10, 3, and 7. What if we would like to get all the items except for the last 2? Then we have to use something like this. The result is going to be all the items present in the one-dimensional array except for the last 2. What's crucial in Python, that we can mix the types. So for example, we can store doubles, we can use integers, we can store, for example, strings, name Adam, and it is going to be valid. So in Java or C or C++, we are not able to do something like this, because we have to define the type of the array, what items we are going to store, whether they are integers, doubles, strings, and so on. Here we can mix these types, as you can see. We can store doubles, we can store integers, we can store strings in the same one-dimensional array. This is why Python is quite a lightweight programming language. Okay, again, we can get, for example, the third item, so index 2, and it is going to return the string Adam. We can update the given value. So for example, if I want to update the string Adam to, for example, Kevin, then we just have to do something like this. And as you can see, Kevin is going to be printed out. So if we print out all the items in the array, Adam has been updated to Kevin because we have updated that given item in the one-dimensional array. What if, for example, we have integers 10, then 42, then 55, then 2 and 1 and 0, and we would like to find the maximum item. This is called linear search, and it has ordo and linear running time complexity. So first of all, we have to define the maximum. Let's suppose that it is the first item of the array. Then what do we have to do? We have to iterate through, and we have to define a given variable in the array. Let's do it, and after that I'm going to discuss what's happening. And if the given number is then the maximum, then the maximum is going to be updated with the number. And of course, finally, we have to print out the maximum. So if I save and run it, then the maximum is going to be 55. So this is called linear search. We are able to iterate over a one-dimensional array with the help of a for loop. So we have to define a variable with which we are going to represent the given items one by one in the array. We iterate through every single item in the array, and if that given number, so these numbers one by one, are greater than the maximum, then we update them accordingly. We can check PyCharm's warning. So in this case, Shadow's built-in name max, we can rename the given items. Here, as far as the comments are concerned, block comment should start with the hashtag, so we can reformat the given file. After that, it is going to be fine without any warnings. Anyways, that's all about PyCharm warnings. So we are able to find the maximum item because we are able to iterate through the array items one by one in linear running time complexity, and we can find the maximum. What if we are after the minimum? We just have to use something like this. So of course, instead of the max, we are going to use minimum, and the minimum here and minimum here. So if I save and run it, the minimum is going to be 0, and as you can see, 0 is the smallest item in this one-dimensional array. So basically that's all about one-dimensional arrays. What's crucial that it uses random indexing, and basically this is the main advantage of one-dimensional arrays. We are able to get the given items based on indices in order 1 constant running time complexity. And of course, we are able to update the given values, we are able to insert new items, we are able to iterate through the given array and do any kind of operations we want. So that's all about arrays. Thanks for watching.